I think the time has come to kick off on the energy stage for the second heat network section run by the UK District Energy Association. My name is Simon Woodward. I'm chairman of the UK DEA. This morning we have three exciting speakers talking about different facets of our sector, different pieces of technology, different pieces of innovation, and I'll be doing the warm-up to kick off just to explain a bit more about what Heat Networks is in terms of the association and who we are. So a bit of an introduction. We were founded in 2010. We were founded with 6 founder members. Those founder members were largely local authorities who thought it was a good idea to have a voice for heat networks in the UK. As you'll see on the next slide, we've grown massively to 160 members now in 2024. At the heart of our membership are the scheme owners, developers, partners, you know, the sort of household names, the EONs, the SSEs, people like that who build, develop and own schemes. And around that, we've got the very important equipment suppliers, consultants, service providers, etc. So there's just a little image. I'm conscious that the numbers won't come out at all clearly at the back, but that's a pie that splits our membership. About 50% of the members either sell some equipment or advise on equipment, and the other 50% either install it or purchase it or develop schemes using it. In terms of other benefits to the members, as well as joining a network of 160 organisations, if you become a member of the UKDA, you also receive a free monthly journal that tells you everything that's going on in the heat network sector. So that's all included in the price, and we'll come on to that at the end. It's a very nominal number. So it's both your chance to find out what's happening in the sector, but also use the internal market within the association to tell people about what you're doing to the other 160 members. The third benefit is we've got a website, www.ukda.org.uk. That's got the full member directory. It's got what we do in terms of webinar, many other things. But interestingly, it's got a free library, and there's over 500 documents in that library. That library contains a lot of documents that aren't published anymore. Quite ridiculous reasons why they're not published anymore, but things that are very useful and quite hard to find. So one of the hidden benefits of joining the UKDA. Member meetings, contact with DESNZ. You're welcome to phone me up anytime you want, ask for a meeting, ask to talk to me about what's going on in terms of heat networks. We also meet daily, weekly with officials from DESNZ. We're instrumental in helping them to develop policy, and there'll be people from DESNZ, the Department of Energy Security Net Zero, on the stand today. And as you can see at the bottom there, there's an attestation from Jodie. Jodie runs the Scottish and Southern Heat Networks business, showing how effective we are at translating what we do into heat network policy. Benefit number 5 is that we run a number of working groups. So when there's a very important topic in the sector, we get together as a collective and we discuss that. So whether it's things like sleeving, low carbon heat network across high carbon heat networks, counterfactuals, so what's the alternative cost to buildings if they don't install a heat network, growing the district heating supply chain, or indeed heat network zoning, we're also responding to consultations. We've only just on the 26th of February submitted our response to the heat zoning consultation that DESNZ are undertaking. Now it's 55 pages we wrote about heat network zoning. If you've never heard the words heat network zoning before, come and talk to us. We're in the heat network zone just over there. It's something coming down the tracks where the government will zone every area in England for heat networks, and they're intending to reach 20% penetration of heat from heat networks by 2050. So that will be the person who picks up that obligation, or the right to develop a heat network zone, will be able to mandate, they will have to obligate people to connect to their heat network as they build it out. Also, and it's not covered on this slide, another word that I keep, or phrase that I keep mentioning to people, things that are coming down the track, if you want to find out more, is the Heat Network Technical Assurance Scheme. Anybody who is anywhere associated with a heat network, you own it, you build it, you design it, you operate it, you will be captured by the Heat Network Technical Assurance Scheme, and that's coming down the tracks in 2025. You need to understand that, because the work that you do will be assessed and certified by Ofgem. And if you don't pass, you will have no legal mandate to run your heat network moving forward. In terms of webinars, we've run a lot of webinars through the years, some of them quite contentious. We've looked at 4th generation versus ambient loop heat networks. More recently, they've been CPD certified. All of the webinars are on our UKDA YouTube channel, so you can download those. And we'll be running a webinar. Our next one is about building strategic heat networks in heat network zones. The one after that will be about system efficiency. The one after that will be about the Heat Network Technical Assurance Scheme. So please do make contact, sign up. Benefit number 7, we run 2 in-person events during the year. We're here for 3 days every year at Futurebuild, and we have our conference and exhibition in the autumn. This year we're planning the UK's first Heat Networks Expo. We're partnering with the government to create that in London, and we're expecting 50 exhibitors and about 500 delegates coming to hear about heat networks across the day. So do please come along to our stand, tap your badge to find out more about heat networks moving forward. Benefit number 8, we've got the training register on our website. So this is a document that has got 100 courses on offer, 25 members offering courses about heat networks. The majority of those are free, so please do download the training register. Number 9, if you join as a member, you can advertise vacancies on our jobs board. That's for free. We don't guarantee to fill everyone, but it's a way of actually reaching out to the sector. It's also a way of finding out what jobs are there in the sector at the moment. Number 10, we've got a podcast channel. We've launched our first podcast on UKDAs, particularly member benefits. And number 11 is the UKDA Awards. So our conference this year, we launched our first series of awards for Rising Stars, Champions, Innovation, Best Practice and Outstanding Contribution. So if you remember in the autumn, you could win an award for Heat Networks. And finally, that's me at the bottom of the screen. My details are there. I'll be on the stand, the Heat Network stand, for the next 1.5 days now. Cost to join as an associate member is £810 a year. Full member is £1,620. So that's telling you a bit about who we are and what the Heat Networks is and the UKDA. I'll now pass you over to the first of our speakers. Our first speaker is Chris Willis. Chris is a business development manager from Aquatherm. Aquatherm are one of our members who make a system of pipes. And I won't steal Chris's thunder, but I'll leave him to talk about it. Over to Chris.
Normally when I talk about pipes, people make their swift excuses and exit, so thank you for coming to my 2-hour presentation about pipe work. As Simon said, my name's Chris. I work for Aquatherm, I'm a business development manager there. So I'm going to take you through some of the green innovations that we bring into the marketplace and how we feel that we're providing some innovation to district heat networks. The first one is green innovation. We're all here to try and reduce carbon. That's why we're all focused on heat networks at the moment. Aquatherm, we feel we do this in a number of ways. The first one is our product. It's a polypropylene pipework, so it is 100% recyclable at the end of its life. When it's finally done its job, it will be recyclable. There is a clean welding process. This is a product which is welded using heat fusion. So essentially butt fusion, where just by using a heat plate, there's no solvents, there's no noxious gases, there's no glues. There's nothing. There's no cost assessments that will be required on a building site. We will look at low carbon production. I've got a couple more slides on that where I'll expand more. But Aquatherm, we are the first plastic pipe manufacturer in the world to hold an environmental product declaration across our range. And as you see at the top one there, we do offer a 10-year extended warranty on all of our installations. So that's up to 20 million euros backed by Deutsche Bank. As I mentioned, we offer an environmental product declaration. As far as I'm aware, we were the first plastic pipe manufacturer in the world to offer this. This is now offered across our entire range. So we previously had one which gave average figures across everything, but this will now cover extraction of the raw materials. This will cover the extrusion process, delivery into the UK, and then the installation and the recycling process at the end of the pipe's life. We have various different ranges, so the pre-insulated pipe is what we're here today to talk about as district heating companies. We do offer internal pipework in buildings as well, which have their own EPDs. Our EPD, as I mentioned, is a full LCA, which is a life cycle assessment. As I said, going right up to the end of the pipe's life and its recycling. What this means, essentially, as done with a study we had with a project in London with Rambo. You see, if I just point out on here. So originally the proposal was for steel and copper pipework to be used inside of a commercial building in London. You see that the total embodied carbon in the project was going to be around 401 tonnes. We were able to, using our EPD, redesign the system into Aquatherm and offer only 114 tonnes of embodied carbon. So a total saving in this project of over 280 tonnes of embodied carbon. BRE, I believe, are here somewhere, and I think those guys will tell you that there's significant funding benefits to projects if you can demonstrate that sort of saving on embodied carbon. That was 2, sorry. The other benefit we see in the marketplace is the in terms of cost. So the material cost is one factor we would look at. So at certain sizes, plastics will be cheaper to purchase than steel pipework. But actually, the installation time and the labour costs on site is where we'll really see a saving. So these figures are quite small. If you want to talk to me about these and get more information, we're over at stand K16. We'll be there the rest of the day. But you can see sort of if we're looking around sort of a 5-inch pipework to do a weld on that, the total time, including the cooling time, before you could liven the system would be 9 minutes and 40 seconds to both weld that pipe and then fill the system with water. Pipes are flexible, they're plastic pipework, so when we're looking at 12-metre runs, if you pick that pipe up in the middle, it will be flexible. In that respect, if there's any hidden services under the ground that don't always become clear until you dig up the roads, then they're flexible to come around it. We won't always need to be adding in extra elbows into the system. The key point at the bottom there as well is that there's no expansion loops required with Aquatherm. When the pipe's buried under the ground, because of the polypropylene properties, it won't be expanding in a horizontal direction. That will just be absorbed within the pipe wall. What this means is, if we look at a project like this that was done in Germany with steel, they had to put an expansion loop in here at this change of direction. You can see the extra civils costs that they've had to incur here, the disruption to this poor kid on his bike, to the local community there. If you did this with an Aquatherm polypropylene pipework, you would save all of this civils costs here. You would best be able to do a straight run in the T-junction there, causing considerably less disruption, less time on site, less waste on site, less material to be purchased. This is a really key factor to consider in a heat network project. Leak detection systems, this is something that's quite new to Aquatherm. We traditionally with a plastic system wouldn't necessarily see a need for leak detection, but in recent sort of projects, it's something that's been required by the end user, the end client. So this is something that would be available. As I said, normally with a plastic, with it being fully welded, we wouldn't necessarily need to see leak detection because there'll be no corrosion if water gets into the insulation foam on a plastic. However, it's sometimes a requirement. So we have 2 options: the 2-pipe system with branders and the VDOS, the tape across the top of the pipe. Again, this information is quite small, but just to give you an idea of the lifetime of the pipework. So where we're looking at sort of the 4th and 5th generation systems here, could quite comfortably offer up to 100-year service for the pipe buried beneath the ground, up to about 14 to 15 bar. As we get warmer, obviously the service life will reduce, but we have pipework in Gateshead, which is operating currently at around 85 degrees as well. So it's quite flexible in what we can offer, and design help's always available from Aquatherm. Again, to get more of this information, come and find us on our stand. We can go for everything with you. The final innovation that we've done, and it's something we've done at the Gateshead district heating system, is to allow hot tapping into a live system. So where this Gateshead system was extended into a couple of extra schools that were being added, we were able to do that without shutting down the district heating network. I'm not the most technical of people, so I can't talk you through it entirely, but essentially you have a prefabricated valve which is welded onto the outside of the pipe. The system will have its temperature lowered to 60 degrees than to 6 bar, and that will allow you to build away from your prefabricated valve. At the end of that, you'll just open the valve and then the system will continue to flow. So there's no need to shut down and cut off the heating system to an entire area if you're looking to extend the district heat network. Other services that we do offer in support, we're aware that it's a fairly new product into the market, plastics into district heating network. So we have a full training service available for any installers, and that's how you come by your warranty. So once anyone's trained, then there is a 10-year warranty on every single installation done by that company. We offer full technical support, so we can redesign systems. We find actually with the smoothing a bore of a plastic compared to a steel pipe that it is possible to downsize the actual design. We know most systems will be designed in steel, that's how they come. But we do have the option we can downsize or increase flow rates if we need to. We offer site support as well as a prefabrication service, and we do offer a full takeoff service as well, so we can convert anything from steel into Aquatherm or to other plastic. And we are all of our products are available on ComSoft, so if you've got a system designed on there, you can do a straight swap straight over to Aquatherm pipework. I believe that's my last slide. There will be questions at the end, I believe, Simon, so I'm sure you all have loads for me.
Thanks very much indeed. I'd now like to invite Stephen Hart to come up. Stephen is from Baxi. I'll allow him to introduce himself a bit more and explain what he does. So I'll hand over the controls to Stephen.
Thanks very much. So I'm from Baxi. Obviously, Baxi is a business very well known for lots of heating appliances, boilers, cylinders, more latterly heat pumps, etc. But certainly we see heat networks as a fast-growing part of our business. And I've arrived at Baxi with a number of years' experience in heat networks, 17 years working for a Danish business where you kind of absorb this stuff without realising it. But nevertheless, Baxi is quite a large business in the UK. We turn over around, we have about 1,300 people here, but we're part of a wider group. We're part of BDR Thermea. BDR, Baxi are the B in BDR, and we're a story of acquisition. That in 2009, the BDR business was formed by Baxi, Dietrich and Remea, which really gave us a footprint across Europe. And importantly, in 2022, BDR Group acquired Fortis Energy Systems. Fortis Energy Systems are the market leader in heat interface units, thermal substations in the Netherlands with over 50% of the market share. So really, BDR Thermea, we're over a €2 billion business. We have nearly 7,000 employees, and we feel we can make a difference. And the difference that we want to make is really the decarbonisation of heat and hot water for buildings. You know, we talk about smart energy systems of tomorrow. Energy systems used to be linear. They used to be based upon fossil fuels. Of course, now we're seeing the move towards renewables, but we're also seeing the need for storage and transmission of energy in various green carriers. And the future is all about connected buildings, connected customers, being able to switch to the most efficient, the most renewable, attractive option at any given time. One of the opportunities that we have at Baxi is that, of course, some of our brands are well known in the UK, like Remea or Potterton or Heat Ray Sadia, etc. But actually, our portfolio of technology across Europe throughout the wider BDR group is very, very significant, particularly in more recent years over the area of renewables. So we also believe that our services, that to be fair have been developed to serve the much more mature boiler and cylinder market, such as our sort of technical support, some of our digital selection tools, and importantly, the fact that we train 7,000 service engineers a year, or heating engineers a year, is important, and the fact that we've got nearly 300 service vehicles on the road to maintain systems. Heat networks are mission-critical systems. It's important we keep them running, and they don't have a failure. But strategically, we believe in 4 H's. We don't know which technology will be dominant in the future, and in true building services style, I would imagine it's going to be a combination of all of these things. And it will be about choosing the right tool, the right source, for the right application to fulfill the right problem. So yes, heat pumps. You know, we've got 4 heat pump factories around Europe. We've got 3 energy centres or R&D centres. You know, but we also believe whether you're putting a hybrid or a heat pump on the outside of a standalone house, you know, we know that the conversations are taking place there about where do I put my modern block heat pump on the outside of my house? Where do I put my cylinder that my house wasn't built to contain, or perhaps I took out 15 years ago? You know, we know that in the Netherlands we're seeing a very big uptake in hybrid heat pumps, where perhaps just like the advice on heat networks, you know, the advice is choose a heat pump to service 80% of your heat load through the year, and then for the very coldest days, maybe it's okay to burn gas as a peak load boiler. That gas, of course, can be natural gas, but maybe tomorrow it's biogas or 100% hydrogen, and our boilers are ready to take any of those sources. But of course, heat networks are now a very big part of what we're offering. One of the businesses that Baxi brought into the group a few years ago was Packaged Plant Solutions, and we turned that into Baxi Packaged Systems manufacturing in our facility in Preston. Here we're manufacturing packaged plant rooms, skidded equipment, etc. And we think that hybrid packaged energy centres are a really big important part of it. This particular energy centre went on the DDAM scheme in the Netherlands. And it shows on the roof a number of cascaded air source heat pumps, high temperature, so you can get 75 or even 80 degrees off in the first floor or on the ground floor. You've then got cascaded boilers. Again, they are natural gas, but they're future-proof through a retrofit kit to 100% hydrogen or biogas, should that occur. And then, of course, we have water storage. Very important we decouple the demand and the supply with enough storage. But this is actually existing. This is a great project. And the deal here was that energy centre serves just over 200 social housing homes, but in an area where actually the total stock is nearly 600. And they've been able to make the network, lay all the pipework based upon the initial 200 with this modular hybrid energy centre. And of course, now they're delivering low carbon, low cost heat and hot water to interconnected homes. So now we're seeing individual homeowners connecting because they want to, not because they're mandated to. So we've got lots of innovations in and around, heat interface units, in and around thermal substations. Some of those, we've got some very big reference projects here in the UK, but we see that, getting involved with the BESA testing, approved products are all really important. But whether we're connecting an air source heat pump, whether we're connecting an HRU, or even a larger thermal substation, actually connectivity is the key. It's the key because, of course, we need to connect energy meters so people can get billed for the heat and hot water they consume or the cooling. But we can also connect our plant room equipment, our heat pumps, our boilers, etc., so we can see what's happening at the plant room. And so if we're also connecting into our electronic HRUs so we can see flows, temperatures, this really allows us to do remote monitoring, remote optimization, and preventative maintenance, because we can now send that through IT devices. Everything's collected on the cloud. We have over 60,000 devices connected to our Mercurius cloud, and it gives us some insights that we can really leverage in terms of communication, where we're using sort of SIM cards that roam to the best network they can get. It means that we've got real-time monitoring. But best of all, we can now take our 270 service vans with Baxi engineers in, and we can start to do remote commissioning. We can start to do automated diagnostics. If something's not right, we can monitor the unit that's not working, and we can detect, is it the unit not working, or is it perhaps a problem in the energy centre, or a problem in the apartment? So we can avoid lots of these calls out that ghost calls used to occur with heat interface units. But we also have automated diagnostics. So our help desks, of course, they were put there to help with boiler installations. But we can run automated routines that can help identify if there is a problem in the unit, which problem is it, what component do we need to send overnight put in the back of the van, so the service engineer, when he does have to go out, turns up and he does first fix rates as good as anything. And of course, it's about planned preventative maintenance to maintain uptime, reliability of mission-critical systems. So, of course, we're doing the smart metering, but it's system optimization. Can we, in the summer months, turn the primary supply temperatures down? Best way to do it maybe is try it, see what happens. So our ability to continuously commission and optimize our systems, supported by our in-house technical ability to select and size the right equipment in the first place, connect it together through manufacturing mechanically or perhaps digitally through wireless systems, and then finally support it throughout the life cycle of the assets with our fully developed nationwide service teams is what Baxi are all about, and is why we've now really enjoyed being a member of the UK DEA. Thank you. If you want to speak to more, there's my contact details on the screen, or we're across at booth K18, where we're showing off one of our thermal substations as part of the UK District Energy Pavilion.
Brilliant. Thanks very much indeed, Stephen. That was a really good talk about what Baxi are doing in this sector at the moment. I'll now pass you on to our last speaker. Unfortunately, our fifth one was taken sick, so Carl Farrows from Seraphi will be coming up to talk about their very interesting technology to look at deep geothermal and how that works. So back to you.
Thanks, Simon. I'm going to stand over this side just to change it up a little bit. So yeah, thanks for letting us speak today. We've got a different approach, a little bit of a different approach to heat networks. Obviously, to get heat networks moving forward and scaling, one of the critical things we need is heat. So basically what Seraphi is really focusing on is the access of a quality of heat which is continuous all the time. As was mentioned with the previous speaker, our whole heat network sort of philosophy is primarily driven from Eastern Europe and Scandinavia, where we've been used to taking heat sources from fossil fuel supplies, waste heat from power generation, from oil, from gas, from coal, etc., and other sources of industry. Obviously, if we're decarbonising, we can't carry on doing that, so we need another type of heat to do that. And, you know, conventionally, we've been looking at ground source heat pumps, a very established business. It's growing, it's still being done, and we're going to continue to do that as part of the process, because not everywhere is suitable for another type of solution. But also in the system we're working with, we're also talking about conventional geothermal. Conventional geothermal is not suitable everywhere, and obviously not everywhere is Iceland, not everywhere is Indonesia, and places where you can drill deep into hot zones and aquifers and create thermal energy. So although it can be done, it's not a scalable solution for everywhere. So having spent nearly 35 years in the oil and gas industry, one thing that I've realised and recognised is that the deeper you go, the hotter it gets. And generally oil and gas, when we drill deep, heat becomes a problem, because we spend a long time trying to cool down muds and various other things to keep the drilling deeper going, otherwise you have problems with drilling. So what we've done is basically a combination of taking that technology into a step further for the ground source heat pumps in drilling to depths of around 1,000 metres, 1,500 metres, 2 kilometres, which is more or less the average temperatures or the average depths we need to get to heat network temperatures, which is 40 to 60 degrees ideally, to give us the temperatures we need for heating and for hot water. So they're the focus points for where we're trying to get to in this sort of, shall I say, next stage of revolution of heat network development. By doing that also, we then provide companies who are manufacturing heat pumps and energy storage systems and various other things a better quality of energy for them to actually use in the process, which reduces their coefficient of performance, or increases the performance, reduces the energy supply they need to actually pump their systems or keep their systems moving forward. So it's an added benefit for their systems to keep that going forward. It increases by depth, but not only the temperature, it also increases the quality of energy. So if you look at a conventional ground source loop, we drill a well, we put a loop in it, we circulate fluids around a 40 millimetre, 50 millimetre tube, and that goes up to the surface. Our designers are using a full system, what we call a coaxial design. So it's using a full bore of the well, fully cased. We flow down the outside of the well, we come back the inside of the well, and because it's running at a very low temperature flow, so we're only flowing maybe a 1.2 litres a second in a fairly large borehole, the conduction's very quick. So the conduction actually goes right through very quick, and we get the full maximum benefit of that temperature at the bottom of the well back to the surface quickly. That increases the performance, it reduces the footprint, so the deeper you go, the less wells you need, so you can actually make projects work in environments where space is an issue. I'll just come on to our next slide, where we have a retrofit scenario of a hospital which was done recently, originally looking at 64 boreholes down to 200 metres. Our equivalent system is 6 boreholes of 1,500 metres, reducing the footprint of roughly around 2,500 square metres to less than 200 square metres. It also increases the quality of energy, but also reduces the cost of drilling significantly. People think that just by drilling deeper, it's going to cost more, but it's not the actual case, because you're increasing the quality of energy, really meaning you need less meterage, significantly less in this particular case, by nearly half. We also then increase the temperature, meaning the heat pump coefficient is increased and the system economics work a lot better. We're able to get costs down on commercial scale products to as low as 2 cents or 2 pence per kilowatt hour from an energy point of view, which is very, very low in this case. To do this, we have to think a little bit differently. So we've been working with overseas manufacturers of typical geotechnic type rigs to increase the weight on bit and increase the ability to drill deep wells with the type of technology we would normally use in oil and gas, but actually applied to a civil engineering and more of a construction-based application. We don't want to include or induce oil and gas costs into this business, because this is a utilities market. It's not an oil and gas business where you get a quicker return and a high return on investment. We've got to look at keeping costs down. So having spent a while in the drilling industry in oil and gas, we've been able to take some of the philosophies from oil and gas into some of the designs of these geotechnic rigs. This is one of the first rigs now going to be coming into the country to be able to drill down to 2 kilometres with a 6-inch hole at the bottom, and obviously the shallower you get, the bigger the hole increases and you can get more energy. These sort of rigs will reduce the cost of drilling deep by order of magnitude. A typical oil and gas rig drilling down to 2 kilometres, similar to what they're doing in Stoke and other things at the moment, you're talking 25,000, 30,000 a day for a rig. This rig is a bare fraction of that in cost of that type of application. So this is what we need to do to move forward to get into that deeper generation. I've got a little video of a project that we've done.
In March 2023, Seraphy Energy was awarded a match-funded grant from the Net Zero Technology Centre, a UK government technology accelerator platform designed to support innovation and technology. The Seraphy well works through conduction. It takes heat that is present at the bottom of the well to the surface, where it is processed for its required energy use. The Seraphy well system uses a pipe of 2-inch high-density polyethylene, or HDPE, to increase integrity and allow the fitting of centralisers and other technical components. Over 160 12-metre sections were welded together on site by the Seraphy team, reaching a total depth of 2,000 metres and using a custom-designed scaffold and injector system. HDPE pipe usually has a low temperature threshold. However, the Seraphy team has broken records installing the system to 2,000 metres and to the maximum designed operating temperature of 90 degrees Celsius. Once the desired depth of pipe installation was achieved, the wellhead was installed and the interconnecting surface pipework was connected to the Seraphy True unit, another proprietary Seraphy design. The Seraphy True unit will operate for a number of weeks, capturing real-time data used to further refine and adapt the performance of the Seraphy well system design. Seraphy has been working with industry experts to ensure accurate measurements of the data that's been collected by using their domain expertise, digital technologies, sensors, controls, fibre optic systems, and the analysis of the data in order to ensure that the production of geothermal heat is reliable, economic, predictable, and safe.
So it's quiet here, all the tests have finished. You've got the results, you've got the data. What did you find?
Well, we run the test really for about 4 weeks. The first test we did for about a week was just to extrapolate and take out as much heat as we could for the well to understand what temperatures, the maximum temperatures we were getting. We had a 30-degree delta, so we were at 70 degrees at the bottom and getting just around 42 degrees at the top. And then the second and third week, we ran the system for various different stages. So we ran it for a period of time, injecting cooler temperatures. To see what the balance of that was from the thermal extraction to be able to increase that temperature to the surface.
And were you able to? Were you able to get the higher temperatures?
Yeah, and also what that simulates is the draw of properties and draw of heat from the system. Just this one section of pipe, because it's taken the heat and the fluid through the system, it's only, obviously, it's not representing a big loop going around, say, like a new development. It's only representing 20-odd metres of the pipe loop. But that's actually demonstrating that 20 metres is sufficient energy to produce energy enough for 22 homes. So if this was 300 or 400 metres long going through a distributed network through a housing estate or something, this particular system could run 300 homes quite easily.
300 homes, that's incredible. Are we talking about some enormous big construction on the side of your house?
No, not at all. I mean, the energy centres we're talking about on these larger developments are no bigger than a sort of large container or a double garage in a property, and they would be sufficient enough to run at least 300 homes from that. And then the connection to the property would just come in with a hot water line which would connect to your heat pumps, and that would be fed literally on tap all the time, so you haven't got to heat it up or get it hot. It's there all the time.
How big is that? Are we talking about that tiny little box there?
Yeah, that is the heat pump.
I mean, are you looking to drill your own holes that are not repurposing an old oil or gas well?
Yeah, we've already started. Yeah, we've already started, and we've started obviously shallow, but we intend to go deeper and deeper and deeper as we do this. And we have to sort of gain public confidence and public engagement to do that. But at the end of the day, there's far more volume of energy in a deeper well using our system as opposed to the conventional way of using sort of ground source heat pumps, which are loops in the ground.
So essentially you're looking at big residential complexes.
Our vision is really looking at what we call anchor loads, so large infrastructure, hospitals, university campuses, business park, enough energy in these locations for them to become sort of anchor loads to then add more to for then domestic and residential users.
In this small corner of Yorkshire, Seraphy have shown what a successful transition to clean energy could look like. And even more remarkably, they've done it with the support of the local community. Now that's a lesson that the whole world can learn from.
Okay, thank you. So that was one of the projects we've done recently, and we've just taken over 8 sites in Yorkshire where we are now connecting these up to heat networks for development moving forward for local communities, villages, etc., to actually use that energy. This particular site, we used existing oil and gas wells, which were come to their end of life. We weren't producing anymore. We've plugged the wells, capped the wells, and now just producing heat from the wells, taking the heat from them wells using our thermal system. The same principle we would apply to drilling the new wells. So the application is the same, it's just using existing well as effectively a donor candidate for that process. Anyway, that's the end of my slides. We have a standover with their group here, and if anyone wants to come by and have a chat, happy to do.
Thanks very much, Carl. So if I can invite Carl, Stephen and Chris to come and take the hot seats at the front, and I'll flick us on. There we go. Okay, so now's the time for anybody in the audience to ask questions. There's a lady over there. If you don't mind saying who you are, where you're from, and who the question is to, please.
Hi, my name is Kelly. I'm a climate, more of a reporting manager, but I guess from a district heating basis for our old terraced housing systems for the whole panel, what's the potential for you guys to come in and retrofit like a whole like estate that's been there for 100 years?
Okay, so retrofitting heat into low-density housing. If we go that way, go on, Carl.
Yeah, I mean, I think, again, starting with the heat, you need the energy, you need the source of heat, and the better quality that you can start with reduces then the issue for these guys and others to actually plug into. So what we've been working with companies like Kenza and others is sort of working on that heat the streets type program or heat area programs. One of our focus points at the moment is looking at bigger infrastructure within towns, cities and villages that you can actually convert first, because what they then do is create an anchor load to tie back to and expand on to then tie into residential and that type of thing. But if you can also start with community-based projects like the project we're doing in Kirby Misperton in Yorkshire, where we have a village which wants to go green. They support the philosophy, so we have the energy. The idea then is you put a network into that village and people then sign up and feed off that network. It's a similar thing. Actually, a terraced type house scenario is quite a easy thing to do, believe it or not, providing everyone wants to connect to it. Putting a deep well or a few deep wells in a location and then running a fairly simple line up the street which people can just sort of tie off is the way to go. We also believe moving forward that using the gas system itself is a way to feed that energy into the house. So where you have existing homes which have gas connections, the gas system itself possibly could be the conduit or the connection point to actually feed fluid through to do that. And that's things we're looking at. So.
Hi. So from a Baxi point of view, your question is remarkably similar to the case study I showed across in the Netherlands. The technicalities, I'm a big believer in the kind of fabric first, You know, if you've got poorly insulated buildings that are drafty, then there's definitely something that you need to take care of there. That would create us the spare capacity to perhaps drop some supply temperatures to the terminal units, the radiators on the system. But of course, you can only go so far in a retrofit. So one of the things that's come to the rescue in recent years is the development of high temperature heat pumps. Now, it's now possible to get something like an R290 propane or natural refrigerant heat pump that can deliver out from a small little energy centre that can go in one of the buildings or perhaps on the end of the street, and that can now deliver 80 degrees. So perhaps you're not that far away from the old 8271 radiator. So that gives us an opportunity. As we saw in DDAM, if you make the energy centre modular and scalable, the big problem about heat networks is if you're going to try and design and spend the money on an energy centre that's there to serve 500 houses at the end, the fact is most start out with 50 houses or 100 houses. So make an energy centre modular and scalable. Buy the plant you need to serve the phase that you want. And as your network builds out, as you get more connections, you build in. And that's exactly what they did in DDAM. You know, in that area, there were nearly 600 houses, but they focused on a single client so they could get the buy-in from the social housing provider. That made a commercial and technically feasible project that they could then invest in. That enabled them to build the energy centre. That enabled them to lay the grass. They got the hearts and minds of the neighbourhood, so they could lay perhaps, flexible aqua heat pipework in the front lawn or in the common area. So reducing, again, the capital costs. So the technology's there. The methodology's there. It's now a social hearts and minds issue. You've got to win the hearts and minds about decarbonising, doing the right thing. But ultimately, particularly with the arrival, the utilisation of heat, with Ofgem being put in charge of the interests of the consumer, even though they're effectively being forced onto a monopoly service, they can be assured that the service levels, the low cost, we as suppliers, manufacturers and designers will be held to account to make certain that we prioritise the customer experience at the very high point of the desired outcome.
It's a very short and sweet answer for me, really, with pipes and retrofitting anything is digging up the roads is the real issue you're going to have. You need to be able to present to a community that it's going to be worth their while to cause months, maybe weeks of disruption by digging up the roads. One thing we have done in a couple of projects in Belgium is trial directional drilling, where the drill piece will basically bore the pipe under the road and it doesn't need to be dug up, but it still causes a small amount of disruption in the community.
Okay, great. Oh, thanks very much. I think we've got a question in the front row here from a gentleman. I saw him put his hand up.
Simon Hodge, I'm a commercial property consultant. That's interesting about pipes, the polypropylene. What's the lifespan of the system?
It's all temperature and pressure dependent, essentially. So, really, the 4th and 5th gen systems will be able to see 100 years lifespan. As you get hotter and higher pressure to some of the maybe waste heat ones, we would maybe look 25 to 50 years, depending on the pressures. But we have found with the Gateshead system, it is at a higher temperature. It is outperforming what we sort of expected to get from it at the moment. So, certainly the figures we get from the factory in Germany they've got quite a large safety factor built into them. So. It's really the lower the temperature, the higher the service life you should see.
Yeah, I mean, I just look at a different thing altogether. But you were Thames Water replacing all the pipes, and they're already cracking, and I would say it's a big concern because cast iron lasts forever, and when they were doing the water, different system obviously. But it strikes me that how can you future-proof the polypropylene? Can you put another band of something around it to make sure it lasts longer, or doesn't it work that way?
It's a good question. I mean, we see the insulation around the outside is an MDPE insulation, so that adds a bit of extra sort of protection to it. But broadly, once it's buried, there shouldn't really be any reason for it to ever come up again, unless you have issues from the outside. So being dug into the top of it when the road gets re-excavated, maybe. But if you're running at a very high pressure, you will have, the pipe would eventually start to wear away. But you're talking sort of over 50 years, really.
Sorry, just to ask the question is to you, really. If you're going down nearly a mile for these pipes, What about the water table? How does that affect it?
So the tubing is cased like in if you were drilling an oil and gas well. So the whole well is cased and sealed. So as you drill, you're actually casing the well, and when you finish,
the level of the water table doesn't matter then.
No, I mean you probably intersect several water tables as you get down, and
go through
you drill through. I mean, we've got a project we're actually drilling through mine shafts and mine water caverns. So you know, you have to protect yourself against that, and like you would in oil and gas, but to control the environment, we case the well all the way down, so it's a fully cased system. We call it closed loop, so it's a closed loop system.
Cool. Okay, I'm getting the signal to wind up. So can we put your hands together, please, for our 3 speakers? Thank you very much indeed. And as I mentioned, all these speakers have got stands just over there. So if you'd like to find out more, talk to them, please do. Thanks very much indeed.